Welcome to this recorded Oscar III Operation and Maintenance Training video. We suggest if you haven't watched our installation video for the Oscar III that you do so before continuing with the rest of this presentation. The rest of our presentation will be the certification process to become certified as a maintenance provider. We'll also discuss what the Oscar III actually is, go through some of the startup procedures and quality control checks, and then we'll cover the basic operation and maintenance inspection procedures. Now, our certification process has 4 basic steps. I'd like to go through those in a little more detail. The first one is once you've completed this video, we suggest that you give us a call. We'll have a brief phone conference, answer any questions you may have, emphasize maybe a few items, and then we'll place your name on our certified list of professionals. That can be found on our website by clicking on the Certified Professionals link. And what that list entails, it'll just be a list of individuals alphabetically by last name. We also include the county that your business is located in. This is not a limitation on where you can perform your services. It's just to give an idea of geographically where you're located. Whatever phone number that you'd like to have us post, and then check whether you're a maintenance provider or installer, and in some cases both. So what is the Oscar system? Well, it's a simple wastewater treatment device. It's a 15,000 gallon septic tank with a 1,000 gallon pump chamber. We pump effluent through a headworks, a series of valves and filters. And then we have what we call the Oscar disposal component for the final treatment and disposal. The Oscar is an acronym that describes what the system is. It's an on-site sand coil area recharge. As you can see here, it's just some simple coils in a simple format connected to some supply and flush manifolds over a bed of sand, and then of course we'll cover this unit with another 6 inches of sand as well. The technology is proprietary. It is a treatment unit, again, and also a final disposal component. We do have, again, the coils and the sand are the basic 2 components of the Oscar drain field. We do have coils in 2 different arrangements, 25 gallons a day as well as 50 gallons a day with respect to the Oscar III. And from a side view, the Oscar is basically a layer of sand that we've put on the ground that's on top of a prepared soil surface. We'll have a minimum of 12 inches of sand under the coil, represented by the red horizontal line, and then an additional 6 inches on top of the coil for final cover. Now you'll notice that really the only place that we have 12 inches of sand is under the coils. The remaining portions of the basal area only need to have about 6 inches of sand. So you may see Oscar systems that resemble this or may have a slight different shape, and this is why they kind of be a little bit odd in that we do have different sand depths. The Oscar, when it's completely been in use for about a growing season or so, could have a lush green grass growth over the top of it. What you're seeing here is just sand over the top of Oscar coils, and again the grass is being subsurface irrigated with nutrient-rich liquid, so it grows quite readily. Our discharge tank is a simple 1,000 gallon pump chamber. We have 2 floats, a timer enable float as well as a high level on float. We do want the bottom float to cover the pump, but as well as a minimum of a 4-inch separation between the bottom and the top float. You may see a greater separation between the 2 floats with the Oscar III, just depending upon what the local regulators may want to see as far as surge capacity. And here's an aerial view of an Oscar that's ready to be backfilled. So now that we're through with what kind of an Oscar is, I kind of want to go through some of the startup procedures, and we'll get into some of the nitty-gritty of the headworks and how things are arranged. But the startup procedures help us to determine the wiring for the floats, pumps, and valves to make sure that they're done correctly, not so much by being able to read wiring diagrams, but more on functional tests. And of course, once we're through with the startup procedures, we'll also know what the correct flows and pressures are as well. Now the startup with respect to operation and maintenance will help us to diagnose problems with the system. Many times I'll get a call, people have questions on what's happening. If they would have just gone through the startup procedures, they would have determined where and about what the problem is. And it just is a great place to start in determining where issues may be. Now the float wiring. We want to determine if the floats are wired correctly in the panel itself, that we've got the right wires in the right bus terminal positions. But we also want to make sure that the float positions within the tanks are correct. They're either at the right height or we've got them in the right order. In our control panel that we use for the Oscar II, the incoming wires for all the external wiring attached to the bus terminal, which is divided into 3 sections with these 2 yellow tabs. Everything to the left of the tabs is for the floats, between the 2 tabs is for valves, and everything to the right of the tabs is for pumps and incoming power. So the way to check the floats, once all the wiring is done, we've turned the system on. We just want to basically, if you lift up the top float, we should, in about 5 seconds, get a high level alarm. If you raise the bottom float, you'd have to wait maybe a few minutes for the pump to come on. An easier way to check the floats quickly is to use what we call the input screen on the controller. Now, the wiring diagram gives us a couple of pieces of information. Here we see bus terminals positions 1 through 4, where our bottom float is in positions 1 and 2, where the top float is in positions 3 and 4. And then you'll also notice at the very bottom below the floats, you'll have input number 1 and input number 2 designating the input indicators on the screen, which we'll look at next. So here we've got a controller, and when we turn the power on, the first thing we'll notice is the little indicator light will illumine. Once it goes green, then we know we've got adequate power and the system is ready to function. So as soon as the light goes green, we get our pump cycles and pump run times. Then we can use the down arrow and scroll down 2 or 3 or 4 screens to the date and time stamp. And from here we can use the left arrow and go over to a screen, our input screen, and we know we're there when we see a large capital I in the upper left corner. There we go. And so what we can see with this is in this top line, it really is the only line that we're looking at. Here we see the number 1 is backlit. That's indicating that our bottom float in the discharge tank is up. So we know we have at least enough water in there to start the on-off cycles. The number 2 indicator would be the high-level discharge flow, which is number 2. And number 3 is usually, say, a low pressure alarm if we were using an ATU with an Oscar system. This particular indicator would be that. So this gives you an idea of how valuable it is to take a look at the inputs. Now if we wanted to test the top float, if we lifted the top float in the situation, number 2 input would have a dark background or be backlit. Again, the position of the floats in the tank. We need to have the pump flooded at all times, minimum of 4 inches between the 2 floats. In our float tree, we really do want to have it come all the way down to the bottom of the tank, and then it's just held up by our float bracket in the riser itself. Our reverse flush headworks has a few more components in there. The headworks, some of the specifications, we do have a 3/4 inch disc filter. The filter is 120 mesh or 130 micron size in filtering capability. We also have 5 normally closed solenoid valves, and we have 3 pressure gauges. Now the solenoid valves, they are actually made for the sewage application. They're not irrigation valves put in the wrong place. Again, all these valves are normally closed, which means that we need to have 2 things in order for water to flow through them. We need to have 24 volts to the solenoid, as well as somewhere between 8 to 15 psi at the valves to get them to open up. If we have hydraulic pressure at the valve but we don't have any electricity, the valve will not open. Now the control panel will go through what I call 3 valve functions. V1, V2, V3. V1 is our dose, where we're just dosing their Oscar system. Our on-off times equate to about an 8-minute cycle between each dose, excuse me. Valve 2 or valve 2 function is our disc filter back flush. It's very short, about 15 seconds. And then our V3 function is where we're flushing the coils, and that lasts for about 2 minutes. Once we're through with the coil flush, then we go back to the on-off cycles, dosing the Oscar. And these 3 valve functions repeat themselves in perpetuity. And of course, if there's no water in the tank and the low-level float goes down, then it just rests and waits for the next sequence to take place. So the valves, they're going to be wired in between these 2 yellow tabs. And if you're at all versed at looking at wiring diagrams, S1 through S5 are the solenoids themselves. Each solenoid has 2 wires. One wire from each solenoid is tied together and will terminate in the neutral or the VN position. Valves 1 and 2 are our dose valves, so they're going to go to V1. Solenoids 3 and 4 are our backflush valves, so they're going to go to V2. And solenoid 5 is our coil flush, so we're going to have that go to the V3. So knowing that we need to have both pressure and flow, or excuse me, both electricity and flow to the valves, we need to turn the pump on and turn valves 1 and 2 on, and this will simulate what the controller would do. And so in our headworks, what will happen is the flow path will follow this green line. Solenoids 1 and 2 will open up, allowing water to be filtered through the disc filter out into the coils. And valves 3, 4, and 5, because they have no electricity, will remain shut. So the flow path will look like this. Now our pressures on our pressure gauges are on gauges 1 and 2 are going to be right about 48 to 52. Gauge 3 about the same. Gauge 3 may be a little bit lower because we're going to be losing some pressure and flow through the tubing and so forth. The flow, depending upon the number of coils that we have, for instance, if we had 10 of the OS50 coils, we'd have a flow rate of about 3.5 gallons a minute. The OS100 coils which are twice the size, have a flow rate of 0.7 gallons a minute. So depending upon the number of those coils, just multiply by 0.7 and you should have a reference point to check with your flow meters. Measuring the flow. We use a NetFM flow meter. How this meter is set up, most people read this incorrectly. The first digit that has the black background is the 100 spot. So if we're reading this dial, we would say that we have a reading of 220, and then to get the single digits, we'd have to look at the first dial on the right. And being that it's less than 1, it would have a 0 in the ones position. So reading it further, we'd have 220.6. The red dial in the middle is tenths of a gallon. You can see it's at 6 or 0.6 gallons. And the dial on the far left, it is 1/100ths of a gallon. So here we have 200.64 gallons on this dial for a reading. So the easiest way, though, to measure flow is if we turn the pump on with the toggle switch and turn valves 1 and 2 on, let the system pressurize so we've got all the air out, and then once we have a consistent flow during complete pressurization, all we need to do is count the rotations on the middle dial for 1 minute, and that'll give us our gallons per minute flow. That's the important number to record. Again, the flow rate, if we're using the OS50 coils, each coil is worth 0.35 gallons a minute. OS100 is 0.7 gallons a minute. The next thing we want to check or simulate is the back flushing of the disc filter. You'll notice that the flow path that we're following here, the forward flow path, is the water comes into the housing of the disc filter, goes from the outside of the disc cartridge to the inside, and then exits the filter housing from the center of the discs themselves. What we're going to do is simulate the reverse flow. We're going to pressurize and have the water flow to the center of the discs, forcing it out, which will then clean the internal portions of the disc filter. So to do that, we'll need to energize valves 3 and 4, put them in hand or manual, and then pump 1 we'll have to put into the hand or manual position. So now valves 3 and 4 will open, the water path will flow backwards through the disc filter, and then we'll vent it back into the beginning of the septic tank. And the flow path will look just like this. To indicate proper functioning, the pressures we should see here is gauge 2 should be about twice the pressure of gauge 1, usually around 20 and 10. Sometimes it'll be 18 and 12 or 18 and 8, something like that. We shouldn't see any pressure whatsoever on gauge 3. The flow we're really not concerned about. Now what will happen in the disc filter, this is a filter that's been in operation for about 8 months. It looks like it's very dirty. We probably would think that it's clogged, but this filter was on a test that was run again for 8 months. The flow and pressure readings were taken 3 to 5 times a week for the 8 months, and there were no changes in the pressures or flows. You can see the red color of the discs. That's where a lot of the water is coming through to clean out the interior of the discs. But this is enough to keep the system functioning at adequate pressures and flows. Once the disc filter has been back flushed, we'll want to forward flush the coils. Again, we need to turn the pump on. This time we want valves 1 and 2 in conjunction with valve 5 energized. So 1, 2, and 5 will turn on. We'll have a forward flow through the coil, through the filter, forward flow through the coils as well, and then the flush water will then enter from the vent line into the tank. And so our flow path will look like so. The pressures we should see indicating that everything has been wired correctly. Gauges 1 and 2 should be about 40 psi. Gauge 3 might register a couple psi, but usually none. And if we were to measure the flow, we want to see at least 12 gallons per minute. Now, you've got psi, but it's 12 gallons per minute flow at that during the flush cycle. So the question becomes what to record for the as-built or for future O&M. The best thing is to record the pressures during dose, 1, 2, and 3, and then also the flow during the dose. The startup's now complete, so we know that all floats, pumps, and solenoid valves are wired correctly. Pressures and flows are recorded. They all seem to be normal. Now when we leave the system, we want to make sure that all the toggle switches are in the auto position and all breakers are on. The easiest thing to remember is everything is in the up position. All the breakers are up, all the toggle switches are up. If we do that, the system is ready to operate in its normal function. Now some of the things that we're going to look for, in addition to maybe going through the startup procedures, is this list here. Green striping, that's just a shorthand that I use to say what do the Oscars look like. And if you'll notice that we're kind of working from the back of the system, well, from the end of the system, going backwards toward the house in a sense. So I try to look at the drain field first, or in this case the Oscar, then look at the pressures and flows, look at the tanks for solids accumulation, and then do my recording of all the data. Now, depending upon the site and the soil conditions, the time of year, the Oscars may look very different, but these are indications, both these pictures, that we have good, well-functioning Oscars. The painting, or the picture on the left, is in late summer, September. Been a very dry year, so the grass in the area around the Oscars dry, where obviously we're going to be dosing again liquid and nutrient-rich liquid to the Oscars. So we've got some pretty good-looking crop circles there. That's an indication that everything is working properly. The system on the right is a fairly young system. It's early in the summer. maybe June, early July, somewhat shaded. So the area around it is greened up fairly well, but you can obviously tell the growth pattern or the wetting pattern of the Oscars. Now here we have an Oscar. This is on the other side of the fence. It's kind of unkept, very tall weeds and clumpy, but to me this is an indication that the system is working quite well, just like the other ones where the lawn's a little more taken care of. The lush green grass is indicating that we've got a good distribution of effluent evenly throughout the Oscar. The sides are in good shape. We don't see any liquid on the ground, so we're looking good in this application as well. Now the problem with this particular system, just kind of as an FYI from a maintenance standpoint, you'll notice the real brown area here. This is all overburden from the tanks. And what they've done is they've placed it downslope from the Oscar. It's hard to tell from this picture, but what we've done is created a subsurface dam by compacting all the soil, and so all this treated liquid from the Oscar doesn't have a place to go, so it's able to get from underneath the Oscar, but once it just moves a few feet, it hits an obstruction and it has to move laterally to the left or toward us. So this would be an indication that not so much that the Oscar has a problem, but the site itself has been kind of manipulated and it's not doing too well. At this point, as far as an operation maintenance tech check, you may want to do a startup process. On the other hand, if you can see that the system has the right pressures, the right flows, the Oscar is working correctly, then we shouldn't have any real need to do the startup process, but they're available for you. Now the septic tank, we're just going to measure for sludge and scum accumulations. When about 1/3 to 1/2 the vessel is full of solids, probably need at least to have those wasted off. Some jurisdictions require all the contents of the tank to be pumped out. Whatever that is, let's make sure that it's done according to local rule. Now the discharge tank, we want to measure the solids accumulation in the tank. If we start approaching the inlet to the pump, we probably want to at least waste off the material that accumulates on the bottom. If you see a little bit of film growing on top of the system or on top of the liquid level in the tank, that's okay. It's not a big problem. If we start to form a mat like we do in the septic tank, we may want to take some action and get that cleaned out. But a little bit of film that's growing on the top would be normal. So the minimum data that you'd want to record, what the condition of the Oscar is, whatever you see. Just state your observations. If you've got effluent on top of the ground, as an example, obviously we want to record that. If there were any damage done for trees falling, obviously record those types of things. Again, we will record the pressures during the dose cycle, flow rate during the dose cycle, and then any accumulations that you have in any of the tanks. I want to thank you for your interest. Please feel free to review this presentation at your leisure. Feel free to give us a call with any questions you may have. Thanks again for your time.